Hello, everybody, and welcome to EduCounts and this series, which is 10 minutes learning. And in this lesson, we are going to discover together the graph of the ceiling and the floor functions. So we have learned before that ceiling and the floor functions are step functions, and we have learned how to evaluate them. So in this part, we're going to learn how to graph them. So let's get started by graphing the ceiling function. I selected here some random values to be used inside the ceiling function that we have right now. And let's remember together what exactly the ceiling function does. So the ceiling function is rounding up or looking for the least integer that is higher than the x or equals to x. So for example, here, if we use 0 in this function, the function, since we have the opportunity to use the integer or the value that equal to x. So if we use x is equal 0, this function will give us 0. And if we use 0 0.5, so we are looking for the greatest integer that is higher than this one, okay, or equal to that one. So the function will round this number up, so there's going to be 1. This one is the smallest integer that is higher than 0 0.5, because there are many integers that are higher than 0 0.5. Same as 0 0.7, so 0 0.7 will be rounded up, is going to be 1, and 0 0.9 will be 1. Once we reach 1, this one would be equal to 1. So if we would like to graph this part or plot these numbers, we can simply notice that here, if we have 1 here, and here is 2, and here is we have 3, and here is we have 1, 2, and 3. So 0 and 0, it would be somewhere here, okay, and then we have 0 0.5 and 1. So 0 0.5 is between 0 and 1, so it's 0 0.5 is going to be up at the point of 1, so this is the my point. And 0 0.7 would be somewhere here, and 0 0.9 it would be somewhere here, and 1 would be equal to 1. And the more you are using decimal, you can see that these points form a segment like that, so except the 0. So once we use any value is higher than 0, it's going to be rounded to 1, and the 0 would be rounded to 0. So we can graph 0, or we can plot the 0 and 0 as an open circle, and any point to the right here would be a closed circle, and then we can erase this point. And if we keep going and using decimals, so the function will take this pattern. So if you use any number higher than 1, this number would be rounded to 2, okay. And if we used any number is less than 2, or the between 1 and 2, so the value of this number would be equal to 2. So I'm gonna graph 1 here as an open circle. Since 1 is not equal to 2, the function, once we use 1, the function will give us an output as 1, not 2. So and anything exactly higher than 1 would be equal to 2. So that's why we make it as a segment, because we have many or an infinite number of decimals between 1 and 2, and then the 2 would be given as 2, and any number is higher than 2 would be 3, okay, like that one, okay. And 2 itself would be rounded to 2, so there is no need for graphing it as a closed circle at 3. So and 3 itself would be equal to 3, and this would be a closed circle. So we can simply notice that we have something looks like the stair or the stair steps. So that's why we call this function as a step function. And we can keep going like that in this pattern. So we can keep this part like this, okay, an open circle to the left, a closed circle to the right, one step down, closed circle here, and an open circle here, then connect them together, one step down, closed circle to the right, and one step to the left, and then match them like that, and one step down, and then a closed circle, an open circle like this. And the domain of this function, as we mentioned before, it would be all real numbers, since if we use the idea of moving over the x-axis like that, if we have someone here moving from the left hand side to the right hand side, so this person can see the graph everywhere, even between any two integers. So someone here can say, but specifically at this point here we have an open circle which is not included in the domain, but this open circle below it a closed circle, and this open circle below it a closed circle, and this open circle below it a closed circle, and you can find that every single open circle it has a closed circle below it. Okay, so all the numbers here on the x-axis are allowed to be used in our domain. Okay, what about the range? Since the range of this function is all the integers, if we use the idea of moving up over the y-axis, we can simply notice that this guy, once this guy reaches this point, so he can see the graph. But if this guy over there at another point, the distance between any two integers here, okay, there is no graph. So if the person here between any two integers or between any two numbers over the y-axis, so he cannot see the graph. So that's why this function only takes the integers, or the range of this function only all the integers. On the other hand, for the floor function, we see that the floor function, the function that rounds down, or the function that looking for the greatest integer that is less than or equal to the value of the x. So if we use 0 in this function, the function will round it down or give us the same value, which is going to be 0. And if we use 0.5, this number would be rounded down to the nearest integer, which is equal to 0 as well. 0.7 would be 0 as well. 0.9 would be 0 as well. What about the 1? The 1 would be graphed or would be 1, since we have the opportunity to be given the same value. So if we would like to plot all of these points, I'm going to say 0 and 0. So 0 and 0 is somewhere here. And what about 0.5 and 0? So 0.5 is somewhere here on the coordinate plane. 0.7 is something here or somewhere here. And 0.9, we are getting close to 1. So it's 0 as well. What about the 1? Once we use 1, we can notice that the function will jump up one step like that. So that's why we called it as a step function. So since we have infinite number of decimals between 0 and 1, we can make our graph like that, and we can mention that at 1 exactly the function does not give us 0. The function will give us 0 if we have any number that is less than exactly 1 and reaches to 0 itself. So we can make a closed circle to the left and open circle to the right, and here we can keep going in this pattern like this. So once we have here any number higher than 1 would be rounded to the 1, and until we reach here 2, the function, once we reach 2, so the function will jump one step up, and this function would be equal to, and then any number is higher than 2 would be rounded to 2, or once we reach 3, the function will give us here 3. So this would be a closed circle over there, and here it would be an open circle, since the 3, its output would be equal 3, not 2, and we can keep going like that. Okay, the same as the negative side. Here we can plot here one step down, and here is we have an open circle, and then we have a closed circle. Okay, and one step down, and here is we have one open circle, and then we have a closed circle. One step down, and then we have an open circle, then we have a closed circle to the left, and so on. So that's why this function called as a step function. It looks like simply or obviously it looks like the stair of steps like that. And the idea of the domain, we already explained that it's all real numbers and the range is all integers like before, as we use the idea of moving over the x-axis and over the y-axis.